Hello students, today's topic is operating energy in the buildings. Recent studies for the World Energy Council and UN Division for Sustainable Development shows that approximately 33% of global primary energy consumption is taking place in residential and commercial buildings. The demand in this sector will be greater than by any other sector till this year 2020. Due to limited resources of non renewable energy, a greater efficient use of operating energy in the buildings is the major requirement at this time. You can classify as classification of operating energy in the buildings are the cooling, lighting system, space heating and cooling, water heating, others like heaters, machines, etc. Energy conservation. Main aspect of conservation of energy in the domestic sector are energy efficient building design and reduction in wastage of energy. Energy efficient building design. The function of a building is to protect the mankind from the extremities of the climate. It can be considered as a low pass filter for the weather parameters where only daily variations affect the inside conditions. The rapid fluctuations in the ambient conditions may not affect the inside conditions to a great extent unless cross ventilation is maintained in the building envelope. In order to understand the dynamics of the building behavior, it is necessary to understand the heat and mass transfer through various building components and then evaluate integrating effects. Though there are many components in a building, but the two most important components are number 1, roof and walls. Number 2, the windows. In the case of roof and walls, the increasing use of air conditioning equipment for creating comfortable living microenvironment contribute to an increase in building energy consumption as the building sector accounts for almost 30% of energy needs in many of the nations. Insulation is the main tool for controlling the energy consumption in the buildings. If you go for the insulation, generally buildings are well insulated in order to minimize heat losses. Insulation may be in the form of different type of paints, thickness of used material, etc. Rate of heat loss U value in the means of joule per meter square per degree centigrade hours is the heat transfer coefficient of construction. It has a relationship with the rate of heat loss of a structure and decrease inversely with respect to the insulation thickness in theory. Therefore, it is possible to reduce heat loss up to any chosen value by increasing the thickness of insulation. The most important factor this issue is the capital cost. And insulating materials are rather expensive, thus it is essential to fix an economic limit for energy conservation in the walls and roofs of the new building. Now come to the second point, energy efficient windows. In modern buildings, however, from the point of view of energy, windows are most important element of the envelope of a building, providing thermal insulation and solar radiation. The net effect of a window on the heat balance of a building depends on the characteristics and orientation of the window as well as on the solar and weather data. Installing very efficient window or energy efficient window is an effective way of reducing or replacing your energy bill and keeping your home warmer and cuter. The heat loss in winter through the windows can be minimized by using airtight double or triple pane windows with spectrally selective film or coating and letting in as much solar radiation as possible. Heat gain and thus cooling load in summer can be minimized by using effective internal or external shading on the window. With conventional glazing, most of the energy consumption of a building goes quite literally out of the window, which provide less resistance to heat flow than walls, ceiling and floor in a building envelope. Even when windows comprise a small area, they are the area of greatest heat loss and gain, and also for the air leakage. In typical houses, roughly one third of the total heat loss is through the glazing. Also, most of the cooling load is due to solar heat gain through the glazing. Further, much of the air infiltration occurs around the edge of windows. On the other hand, there is a potential of energy saving from daylighting as well as solar heat gain in winters. For understanding the phenomena of heat transfer in window, it can be divided into three components. Classification of phenomena of heat transfer in windows is divided in three parts. Number 1, center of glass, edge of glass, and number 3, window frame